Okay, this video is going to explain matched pairs, which is a concept that is easily confused with two sample, but is run just like a one sample procedure. So you should have a similar document to this with this bullseye activity. So at the top there, it says preparations. The objective is to see if there is a difference between left and right hands. So since we would take two measurements on one person and check to see if there was a difference, that's what allows us to use matched pairs design. The coupling bias and variability, some of the things listed there, we typically ended up doing something like both hands had to be sitting on the desk with the plate of candy in between your hands, and just in front of the plate of candy was the bullseye. The timer would start when you lifted your hand off the table, and it would finish after you've placed all of your candies in the appropriate spot once you put your hand back down on the table. So I believe the document you have references Smarties instead of M&Ms. They tend to roll away a little bit less. If you want to read some more about the activity, you can pause the video and do that. I'll also share this document. This document is actually from a few years ago with a class that was able to collect our data. So you can see initials of everyone that are listed there. We looked at the dominant hand minus the other hand with the expectation that the dominant hand would be the faster of the two hands. So it really wasn't a left versus right when we were done with it. That was just how we discussed it at the beginning to explain why your two hands would end up being a matched pair. Everyone highlighted in yellow is a female. We did split it and look at males versus females for a two sample test after the fact. So for a one sample test, we have one list of data. Matched pairs is the same thing. The key here is that we are looking at the list of differences. And so in this case, we did subtract dominant minus other. For the null hypothesis, if there were no difference in the amount of time it took to place the candies, then that would be equal to 0. And we used a little subscript difference. That was just another communication piece to recognize that we were in fact looking at that list of differences. Because we subtracted dominant minus other, thinking dominant would be faster, we would have smaller numbers minus larger numbers and end up with negatives. And so that's why it was less than 0. It could have been subtracted the other way. It would have been greater than 0. To randomize, in this class, they decided to toss a coin to decide which hand would be done first. And so if there were, for some reason, some sort of bias introduced by having practiced with one hand that happened to be the dominant hand as opposed to the non-dominant hand, then the coin toss seemed to randomize which went first. So individuals weren't randomly selected, but which hand was used was randomly selected. And then everyone should have been independent of one another. No one's time should influence anyone else's. For normal, we only had a group of 19. So we took a look at the box plot. There seemed to be the one outlier. And with this sample size, we thought that slight skewness would be okay, but outliers we should be cautioned against. Sam happened to be an outlier for whatever reason, and so off to the side we wrote the caution is not met, or the condition, sorry, is not met. Because this is not met, our probability calculations might be inaccurate, so we said proceed with caution. This test statistic, this is the same one that we use, again, with one sample procedures. We're just taking a look at the differences. And so for this particular one, in approaching the AP test and what needs to be done, if you list the formula itself, you can list all of the values. So what X bar, S, and N were equal to, degrees of freedom is simply 1 minus the sample size for this. And then the t-test was by the calculator. The negative 2.2286 at 18 degrees of freedom. This again would have been done by the calculator, not by the table, or we wouldn't be able to get that exact value. If the outlier is removed, we ran this test a second time just to see the difference that it makes when that outlier is present. we have much stronger evidence. It ends up being much farther away. So you can see from the normal condition up above that for whatever reason, Sam ended up being much slower with the dominant hand. So we had a positive number. And because the mean is not a resistant measure of center, that mean was really pulled up much higher than it would have otherwise been. If you take a look at the box plot, it's again a very rough sketch of the box plot. But so my test statistic went from my negative 2.286 down to negative 3.92. So my p-value is much, much smaller. So conclusion that we always have our normal parts. We now have very strong evidence to reject H sub O at any significance level, we said, because we were working without the outlier. If there is no difference in times between dominant and other, we would see improvement such as ours only 0.05% of the time. So this, again, this 0.05 is converting this decimal point into a percentage is all. And so making the decision to reject, interpreting the p-value and doing so in context are the things that we're looking to highlight. Again, otherwise, this is just like a one sample test. So the confusion may be that if you were just given the original data, just dominant and other, you're sometimes given the list of differences. Sometimes you have to find the list of differences. You are sometimes given only the list of differences. In that case, it shouldn't be too confusing whether it's a matched pairs test or a two sample test. But hopefully it makes sense where if you would see the two lists and you have to recognize whether to treat them as two independent lists, if they come from two distinct samples, or in a case like this where we have two measurements from each person in our sample of 19, which is what makes it a matched pairs t-test. And we could perform the calculations for a confidence interval for this as well.